Hello and welcome to this R-Instat video about climate normals and missing values. The WMO set of principal normals is as follows. So far, for the two stations in Ghana, the two precipitation normals for 1981 to 2010 were found. For example, the normal for the total rainfall in June at Salt Pond was 222 millimeters, and this normal was also shown by the middle line in these graphs. The second principal normal was the monthly number of rain days, as shown here. For example, again in June at Salt Pond, there was an average of 12.8 rain days in the month. That's also shown by the height of the top bar in the corresponding graph. Among the other precipitation normals, we also found the largest daily value. In June at Salt Pond, the record value for a single day over all 30 years was 215 millimeters. The WMO guide distinguishes between four main types of summary depending on the first stage of calculations, going from the daily to the monthly data. They can be a sum, like the total monthly rainfall, a mean for temperature, a count, like the number of rain days, or an extreme, like the maximum daily rainfall. This type dictates how to cope with missing values. The total hours of sunshine is another principal parameter. Like the precipitation, it's proposed as a monthly sum. First, a quick exploratory check of these data. In one variable summarize, choose the rainfall, temperature, and sunshine variables. The data for the sunshine hours are between 0 and 11.9, which seems reasonable. The results also show that there are more missing values for the temperatures than the rainfall, and there are considerably more still for the sunshine data. Though with 21,914 values overall, this is still less than 10% of the data. Use an inventory plot to examine the missing data for the temperatures and sunshine in more detail. We add the minimum temperature, maximum temperature, and sunshine hours. Then we choose facet by element and stations. One aim here is to examine the options in the WMO guidelines for dealing with missing values in the data. The results for Tmax show a slightly different pattern at the two stations. At Salt Pond, data are missing roughly a month at a time, while at Tamale, there are often just a few days missing. In both cases, it's mainly in the early 1980s that the values are missing. For the sunshine data, the same years are patchy, and there is also another missing block in the late 1990s. One possibility is to delay the calculation of the normals and to add or estimate some of the missing data. Many options can be considered for that. For example, these stations are synoptic, hence hourly or 3-hourly data exist and could perhaps be used to infill daily values. Here we proceed with the data we have. For the temperature data, the normals were calculated earlier, without mentioning the missing values. What did we do then? This was the dialog which summarized the three temperature variables. In this dialog, the Omit Missing Values checkbox remained unchecked. This dialog acts on the Ghana normals data frame. It produced the monthly summaries. In this case, these are monthly temperature means. What did it do with the missing values? A At Salt Pond, there was a missing block. It's right here, the results are missing. For Tamale, we see the monthly summaries are also missing, though sometimes just because of 1 or 2 days missing in the month. This is therefore very strict. The WMO guidelines allow some relaxation, depending on the type of summary. Here we produced means. For the rainfall normals, we produced sums, so the total monthly rainfall, and the guidelines suggest no relaxation there. When normals are counts or means or extremes, then the guidelines suggest some relaxation is possible. Try this with the temperature calculations. Go back to the last dialogue. Select Omit Missing Values and Missing Options. The current recommendation is that means may still be calculated if there are less than 11 missing values in a month and less than 5 consecutive days are missing. That's what's shown here. The guidelines recognize that some countries have adopted a stricter 5-3 condition, allowing for only 5 days to be missing in the month and 3 of them to be consecutive, like this. They may wish to continue with this. We will try with the current guidelines. Originally, Tamale had 33 missing monthly means out of 360 overall. Now there are just 15. For the temperature data, we also calculated 4 extremes. For example, Tamale's maximum temperature in February 1981 was 41.4 degrees, while the minimum was 27.9 degrees. The guideline is seemingly more generous here, namely, use all the data that exists. That is the standard option in R and hence R-Instat. We illustrate with the minimum for T-mean and T-min, as shown here. We add minimum temperature and mean temperature. Click Summaries and select Minimum. We untick both limits in the missing options, but keep the tick overall. Now it gives the minimum even if just 1 day in the month is measured. This has now recalculated the last 2 variables, and far fewer months are now missing. In fact, I don't see any missing in those variables. So I'll scroll down and find some. The only missing values now are when the whole month was missing. Now let's move on to the second stage. This is the summary over 30 years to give the monthly normals. It reduces the 720 values to the 24 shown here. The WMO guidelines are simply to have at least 80%. So 24 years of data to be able to do this. Here with the temperature data, this is clearly the case. The 80% rule applies to all types of summary. The third stage is then to get the seasonal or annual summaries from the monthly normals. Here the one rule is that if any month is missing, then the annual summary is made missing too. Notice that the means are an average from all 10,000 days, while the extremes are usually just a single day. For example, from the daily data, the minimum ever temperature is 11.9 degrees in the 30 years at Tamale, and that was on the 9th of December 1986. Returning to the daily data, now consider the missing value rules for the normal rules for the sunshine data. Like the precipitation total, the initial calculation is a sum. The guideline for calculating sums is strict. It's what we used in the previous videos, with the monthly summary missing if a single day is missing. For total rainfall, this seems clear. There is also a useful caveat. That is, if the missing rainfall values are estimated, then they may be used. This is subject to the limitation that there should not be more estimated values in a month than the rule for missing values when calculating a mean. Using values from neighbouring stations is sometimes reasonable for rainfall. Having created our sum sunshine hours variable, it's on to the second stage. Here we will also check that there are sufficient years. In the column statistics dialog, we add the sunshine sum as our variable. To check that there are sufficient years, we select number non-missing as well as the mean. We now have monthly summaries, but some months slightly break the 80% rule. Countries could perhaps consider the sunshine hours as a count rather than a sum. After all, it is the count of the hours of sunshine. Counts permit the same rules for missing values as means, so returning to the daily data, change the missing rule as before. Next, we repeat our column statistics step. The dialog is already filled. We just check it over and click OK. Now we have the monthly sunshine totals, and there are sufficient years of data for calculations. There is one additional step suggested by the WMO guidelines for count type normals. We leave you this as a challenge, which we'll address in a small supplementary video. Because of the missing values in the daily data, the counts shown here are not always on the complete months. An example in these data were in June 1984, where the total hours are quite low, but are also only over 28 days. How could this be adjusted? Apart from this challenge, you should now be able to calculate normals and adjust for missing values where necessary. Thank you for watching. Bye.